Hello, in this topic now we will see the derivatives of all the functions. All the functions that I can see, we can calculate them using some simple laws. Let's see one by one the cases. First case, fx equals c. What's the derivative of that? It's 0. Now, for example, fx equals 5. What's the derivative of that? 0. Let's say I have fx equals 1.2. What's the derivative of that? 0. All the numbers, the constant, the derivative of these constants must be always 0. I think that's very easy concept. Let's see next function. Fx equals x. Fx equals x. What's the derivative of fx? 1. Now I want you to see, let's say that I have fz is z. What's the derivative of z? Which is the variable? Z. How much is it? Z. What's the derivative? 1. Easy. Now here the power rule. Fx equals x to the power of n. What's the derivative of that? N. So this n goes in front of, so as to remember it, and then I have x to the power of n minus 1. For example, let's say fx is x squared, then the fx derivative will be 2x, 2 minus 1, how much is it? 2x1, which is 2x. Another one, x to the power of 11. How much is the derivative of fx? 11x to the power of 11 minus 1, so 11x to the power of 10. Now what happens here? 1 over x to the power of 5. What's the derivative? Now here, if I'll go back, do I have any function that looks like this? No. So what happens in this case? Now it's very easy. First, before calculating the derivative, you see I'm keeping the bracket and I say I want to calculate the derivative of that. I can write this fraction using the exponent's law, x to the power of minus 5. So how much is the derivative now of that? X to the power of n, because it's the same, as you see. It is minus 5, I take all the power in front, x minus 5 minus 1. I follow exactly as the formula says. So it is minus 5 x to the power of minus 6, which I can write it minus 5 x to the power of 6. This one I can move it and write it as a fraction. If I'll make it more, 1 over x to the power of 6, which can be written like this. Apart from this case, I have another case, which is sorry, I don't need to erase them. The other case is if I have fx equals square root first of x. Now how much is the square root of x? How much is the derivative? Now again, I don't know, I don't have any formula for the square root, but how I can write the square root? I can write it before calculate the derivative x to the power of 1 over 2. Be careful, these are exponent laws, so you have to practice them. Now I can take again the derivative of that, which is nx to n minus 1. So basically here, n in front, x to the power of 1 over 2 minus 1, which is x 1 over 2 minus 1 is minus 1 over 2, if I'll make the fractions with common denominator. But again, how I can write this one? This one I can write it 1 over 2 times 1 over, this one can be written x to the power of 1 over 2, which is 1 over, again this is the square root of x, so basically this is 1 over 2 square root of x. As you see, everything is connected with the exponent, the power law, as we call it. Now there is another case of that where I can have a little bit more complicated, which is the third root of x to the power of 7. What's the derivative of that? Again, here I will write it as a power, x to the power of 7 over 3 derivative, which is 7 over 3 x 7 over 3 minus 1, which is 7 over 3 x to the power of 4 over 3. Don't forget, I make some common denominator, and I have that. Where I can write it? Cubic root of x to the power of 4. Of course I can simplify it more, but I like to keep the things, I like to keep things more simple. Now next, ln x, I think it's obvious. Ex is the same, sin x, and here let's see the last case, fx equals 2 to the power of x. So here I can write it, if I want to calculate the derivative of that, will be 2x times ln 2, and that's the derivative of this function. Now all these cases are the simple ones. The next level that I have with the derivatives, that I will have a combination of all these, which means what? The first case is that when I have two functions, f plus or minus g, and I want to calculate the derivative of them, then it will be the derivative of the one plus or minus the derivative of the other. What do I mean? If I have the derivative, they will tell me calculate 2 plus x cubed, and I want to calculate the derivative of that. Since the operation that happens is plus or minus, it's the same, I can say that I can calculate the derivative of 2 plus the derivative of the other function. What's the derivative of 2? You have to remember the constant is 0, so it's 0 plus, and this one is a power law, 3x squared. So the answer is 3x squared. Exactly, it can happen with all the other functions. So x4 minus sine x, let me put another one, plus ex. I will take the derivative of each one separately. You can do it, of course, immediately, but for the time being I will do it separately, analytically, like this. So it's 4x cubed minus, this is cos x, plus ex. This one stays the same. Now the next one is that I can have a constant times a function, the derivative, which is the constant times the derivative of the function. What do I mean? If I have to calculate the derivative of that. 3x to the power of 5. Be careful. Here, because I have a multiplication of a constant times the function, the power here, I can calculate the derivative by doing what? 3 times the derivative of the function, which is 3 times, what's the derivative of that? 5 times x to the power of 4. So it is 15x 4. Be careful, it's not the derivative of 3, which is 0 times the other. If it's multiplication, I just pull the constant outside of the derivative. So if I will have a combination of the previous one and this one, let's see it. So let's say I have 3x squared minus 5 cos x plus 7ex, and I want to calculate the derivative. What will happen? The derivative of the first minus the derivative of the second. Be careful, because later on we will have product rules and the quotient rules, but now it's not the case. Plus this. So here you see it's the constant times this function, so it is 3 times the derivative of x squared minus 5 times the derivative of cos x plus 7 times the derivative of ex. This is 2x, so it's 6x minus 5 times, this is minus sine x, plus 7 times, this is the same. So the answer is going to be plus 5 sine x plus 7 ex. Be careful, this is a case where many people get confused here when I have to multiply a constant with a function. So now you see this, the addition and the subtraction law times the constant and the function, it's one of the basic differentiation laws, a combination of the basic ones. On the next video we will see the product rule when I have, for example, f times g, and the quotient rule when I have f divided by g.